geometry students. Today we're going to be talking about transformations again, but in the coordinate plane. So have you ever had any experience with a marching band? I know I have. With a marching band, the football field is basically just one big coordinate plane. So at the beginning of the season, the band directors give out basically a plot of where each band member has to stand. So you can kind of think like each band member is basically a coordinate point. And so throughout their performance, each band member is making a transformation. Transformations are occurring all over the field until you get nice, pretty pictures like so. So let's talk about how transformations occur in the coordinate plane.
Here are your standards that we will be addressing in today's lesson. And the second standard is really kind of the main one. Given a geometric figure and a rotation, reflection, or translation, draw the transformed figure using graph paper, tracing paper, or geometry software, and specify a sequence of transformations that will carry a given figure onto another. And here are your specific objectives. Explain why transformations are functions, classify a transformation given an ordered pair rule, draw an image given a pre-image and a description of the transformation, and draw an image given a pre-image and an ordered pair rule. So before we get into the lesson, let's talk about some information that you need to recall. So let's look at a coordinate plane. Remember that coordinate planes are divided into 4 quadrants. We have quadrant 1 in the top right corner, and then it goes counterclockwise around quadrant 2, quadrant 3, and quadrant 4. Okay, let's review how to name the coordinates for some of these points on the coordinate plane. So remember, a coordinate or ordered pair, you start with your parentheses, then you put your value for the x coordinate, a comma, the value for the y coordinate, and then you close your parentheses. So the x coordinate represents how many in what direction you go on the x-axis, and the y coordinate represents how many you go in what direction on the y-axis. So if we start with point A, and we start at the origin, to get to point A over here, start with going left on the x-axis toward point A until you get to the line that lines up with point A. So that brings us all the way to -6, which makes sense since we went to the left. Then from there, you want to go up or down to get to point A. We need to go up until we get to the point itself, and we landed at +2. So the coordinates for A are -6, 2. Now our first objective is going to be to explain why transformations are functions and to classify transformations given an ordered pair rule. So mapping rules. Remember from Algebra 1 that a function is a relation in which each input results in exactly one output. So remember, your inputs were your x values and your outputs were your y values. X mapped to y, and every x had only one y. So the same can be said about a transformation. We can describe them with a mapping rule in which every input, which is represented by the point on a pre-image, corresponds to exactly one output, or the point on the image. You're not going to have a point on a triangle after it's translated have 2 places. Every point on the triangle is represented one time in the pre-image and one time in the image. So our first rule is going to be reflection. So remember that the only thing we needed to know for reflections was what are we reflecting over. Here are the 3 most common lines that we can reflect over, but they are certainly not the only ones. And here are the mapping rules for each of those three. So the mapping rules all start with an ordered pair x, y. So this is your original coordinate points on the pre-image. And then it shows you what the new coordinate point on the image needs to look like. So for example, the x-axis rule states that if you start with your coordinate point x, y, your new coordinate point needs to be x negative y. So all you do is change the sign on the y value. So let's say that we were going to start with a coordinate point 2, 1. Okay, we'll just use that point as our example. If we were going to reflect that point over the x-axis, all we do is change the value of the y-coordinate. And so the new point would be 2, negative 1. That's it. If we wanted to do the same point reflected over the y-axis, we can see that the rule states that the sign on the x value needs to change. So it would be negative 2, positive 1. Now what happens in reflecting over the line y equals x, which you can see depicted here? What happens with these coordinate points? You can see that all it does is switch. It switches the x and the y around. That's it. So then, if you were going to start at the point 2, 1 and reflect it over the line y equals x, your new coordinate point would be 1, 2. They just switched around. Now in this last column, you can see another way that you might be shown information about a reflection. So reflections use a lowercase r to denote that that's what you're doing. And then underneath the lowercase r, you will see what will be reflected over. So the line that you will be reflecting over. So to reflect over the x-axis, you would see r sub y equals 0. Okay, let's use this mapping rule, x, y, to x negative y to reflect the figure across the x-axis. So if you take each one of these points, all you have to do is change the sign on the y value. So 4, negative 1 is going to go to 4, positive 1. 4, negative 2 is going to go to 4, positive 2. And 1, negative 1 is going to go to 1, positive 1. So when I plot those points, and then of course you need to connect the lines for your shape. Let's try one where we need to reflect across the y-axis. So the directions say which rule you need to remember to use to reflect across the y-axis. You just need to change the sign of your x values. And then you can also see where the coordinate points are. If you have two of them that are actually on the y-axis, they're not going to move anywhere because you can't change the sign of the 0. Then the point A, since it's at negative 1, is going to change to positive 1, 0. So it's going to go 1 to the right. That's where that triangle would land after a reflection across the y-axis. Okay, try these. Write the ordered pair that represents the image when each point is reflected first across the x-axis, then across the y-axis, and then across the line y equals x. So how many of those did you get correct? Now let's talk about rotations. So remember that with a rotation, the information that you need to know is where the center is, what it's being rotated around, and how many degrees it's being rotated, as well as what direction. So here are just a few common degree numbers that you can do rotations for. Listed here, you have 180, and then you have 90, and then you have 90 clockwise. And so then I didn't put counterclockwise here because remember it's assumed that it's counterclockwise. So here are the rules for each one of those. For 180 degrees, you just change the sign of both of the coordinates. For 90 counterclockwise, you switch the location of the x and the y and then change the sign on the y. And then for 90 clockwise, you switch the x and the y but change the sign on the x. Now in notation, we would use a capital R for this. And then the subscript, the little numbers and things at the bottom, C tells you the center, what we're rotating about. And then theta is a Greek letter that represents degrees. So that's how many degrees you're turning. So 0 for the origin and 180 degrees for the rotation. Here we have negative 90 because that would be clockwise direction. Alright, so let's practice. It reminds us what mapping rule to use and that this is for a figure that is rotating 180 degrees about the origin. It's so considered counterclockwise, but when you're rotating 180, it doesn't matter which direction you go because it would be the same either way. So all you do is just change the signs on each one of the coordinate points. So A is going to become positive 4, negative 2. D is going to become positive 4, negative 1. B is going to become positive 1, negative 2. I'm just changing the signs on both values. And C is going to be positive 1, negative 1. So then when you plot those, you can see where the rectangle rotated to. If you notice, this is the same rule as reflecting across the line y equals x. Same exact rule. Okay, let's try this one. Use the mapping rule negative yx to rotate the figure 90 degrees counterclockwise about the origin. So we have 2 points on this line segment, and we know that we need to switch the x and y values and then change the original y values sign. So A, if we switch them around, we still just have 0, 0, and then you can't put a sign on the 0. So A is going to stay 0, 0. Then B, when I switch them around, I end up with 2, 4. And then I have to change the sign on the original y, which was positive 2. So now it's going to be negative 2. So when I graph that, and there is your segment after a 90-degree counterclockwise rotation. And then our last transformation is translations. So for translations, you need direction and how many. So for the left and right, since that is representative of the x-axis, you add or subtract that value to the x-coordinate. So h represents how many spaces it moves. Then up or down represents the y-axis. So all you do is add that value to the y-coordinate. And you can do them all in one together. So you can have x plus or minus h and y plus or minus k. We put plus or minus because it can go be positive or negative there. Okay, you don't do both of them at the same time. Now for the notation, this one, T for transformation, and then HK tells you how many and in what direction. So if H is negative, then that means it's going to the left. If H is positive, then it's going to the right. Now this is another way that you can write it. That's called vector notation. So you could have the name of a vector down underneath that. Alright, so let's try this one. So the mapping rule that they want you to use to translate is x minus 2, y plus 1. So x minus 2 means to go 2 to the left. Y plus 1 means to go 1 up. Okay, so we can count each individual point. If I started with A, we can go 2 to the left and then 1 up, and that's where A prime is going to be located. We could also take the points and do the math. So since it's x minus 2, I can do 1 minus 2, and I'll get negative 1. And then since it's y plus 1, I can do negative 1 plus 1, and I'll get negative 1 for the value of d. So you can look at that either way that you would like to. So down 1, left 1. That's d prime. Okay, so b prime is going to move 2 to the left and 1 up. And then c prime is going to move 2 to the left and 1 up. So here's where the square lands after the translation. Okay, which type of transformation does this rule describe? This is a translation, because it is simply adding a 1 to the x value, and so all that's going to do is move every point to the right 1 space.
And the y values stay the same, so it doesn't shift anywhere up or down.
Okay, that was the end of our first set of objectives. Now let's move on to draw an image given a pre-image and a description of the transformation, and then draw an image given a pre-image and an ordered pair rule. So, descriptive transformations, you can just do several transformations at one time. So if a figure is rotated 180 degrees about the origin and then translated 3 units up, so that's 2 different transformations. Okay, remember that the mapping rule for rotating 180 degrees about the origin is negative x comma negative y. And then if we are translating 3 units up, that means our mapping rule would be x comma y plus 3. So we need to apply both of these rules together to write one new mapping rule that shows both of those transformations. So essentially we can start with the negative x, negative y. But then we need to apply this rule to this step here. Okay? So since I know that if I take my original x, it doesn't change. And so in this case, my original x is going to be negative x. And then as far as the y value, I just need to take the y itself and add 3. So here, since my y value is negative y, I'm going to do negative y plus 3. And so that's your final mapping rule there. That rotates 180 and then translates 3 units up. Okay, let's try this one. Determine the coordinates of the image of the given point for the given transformation. So point P reflected across the x-axis. So remember the mapping rule for reflecting across the x-axis is that the x values actually stay the same and the y values all go negative. So if I plug in the information for point P that was originally 2, 5, it will map to negative 2, negative 5. Determine the coordinates of the image of the given point for the given transformation. Point Q, negative 3, negative 7, is rotated 90 degrees counterclockwise about the origin. So remember this mapping rule is your original point, the values are switched, and then the y becomes negative. So if your original point was negative 3, negative 7, then my y value was here, negative 7. But I need to change the sign. So since it was negative 7, it needs to become positive 7. Then my x value, right here, is represented by negative 3. So I just stick that at the end. And that's my new coordinate point. That's all for that objective.